Hello friends, welcome to Engineering Funda family. In this video, I'm going to explain you very interesting topic, that is DMA, Direct Memory Access. In my previous videos, I have explained you how exactly interrupt driven IO is there, as well as I have explained you how programmed IO is there, right? In interrupt driven IO, I have told you there are some issues related data transfer from disk to main memory. In that, you cannot transfer data from disk to main memory without involvement of CPU. And as if you wanted to have data transfer from disk to main memory without involvement of CPU, then that is only possible as if you go for DMA. So here in this video, I'll explain you how exactly we can transfer data from disk to main memory without involvement of CPU. Now, before I explain you how exactly everything is happening, let me tell you how many things that I'm going to cover in this video. Like in this video, I'll explain you how DMA functions. After that, I'll explain you how DMA modes are there, like cycle stealing mode is there, as well as burst mode is there with DMA. And then I'll explain how timings are there, like preparation time and transfer time. Based on these parameters, you can be able to solve any problem related DMA. So here I'll explain you each and everything along with examples, so that will give you more clarity. So let us try to understand first how exactly direct memory access functions. So first of all, CPU will generate IO command. So here CPU will place IO command over system bus, right? So what are the information which is there inside IO command? First information, that will be the related port number. So here what CPU says is, here at IO, at whatever port we are dealing with to transfer data, that number will be given. Like for example, here at IO port, disk is there, right? So with this port, there will be well-defined number. So that number that will be placed over here over system bus, and that data will be given to direct memory access, right? Now second information, that is the regarding memory address. So here, what is our agenda? Our agenda is to transfer data from disk to main memory. So inside main memory, you should be having well-defined physical address at which we are dealing with to transfer data. So that memory address, that is also given over here in IO command. Third essential information will be count. What is the meaning of count? Let us try to understand that. See, for example, CPU says you can transfer 32 bytes of data. Now let us consider here one word size that is equals to 1 byte, right? So once this count is given over here, once that count is given over here, that will be loaded inside counter. So what will happen is, once disk is transferring 1 byte over here inside main memory, that counter value that will decrement by 1. Again, when disk is transferring second byte, again counter value will decrement by 1, and it will decrement till its value reaches to 0. Once value reaches to 0, you can say data transfer is completed over here without involvement of CPU. So that is the information which is given by CPU in terms of IO command over here. So value of count that will be given over here, right? And next information is the related control signals. So control signal means here you are dealing with to write data or you are dealing with to read data. This kind of control information that will be given over here. So first thing that is been done by CPU is to give IO command, and that IO command that will reaches to direct memory access, right? Now once that IO command is given by CPU, CPU job is completed now. Now CPU will not bother about what is happening over here. Means CPU is free to execute other tasks, right? Now what will happen, you see. Now direct memory access is having idea about port number, memory address, count and control signals, right? So now direct memory access knows from disk to main memory we are dealing with to transfer the data. So direct memory access will wait till disk is giving DMA request. So here DMA request that will be received by direct memory access from disk. What it indicates? It indicates now disk is ready to transfer data over here to main memory. So that is the second step which is happening over here, right? So now disk is ready to transfer the data over here, but transfer will not begin. Now in next step, what will happen? You see, once disk is free to have a transfer of data over here, direct memory access will give control signal to CPU as hold control signal. So this is the third step. Now what will happen in this? See, when direct memory access gives hold signal to CPU, what it indicates? It indicates that now DMA wants to transfer data to main memory, and that's why DMA wants control over system bus. See, without having a control over system bus, DMA cannot transfer data from IO to main memory. So hold signal will be given to CPU. Right now, system bus is there in the control of CPU. With hold signal, DMA is asking for control over system bus, right? Now, in response to this, CPU will give hold acknowledgement to direct memory access. That will be the fourth step. So hold acknowledgement explains you what? It explains that DMA can take control over system bus, right? So that acknowledgement will be given by CPU over here. Once hold acknowledgement comes to DMA, what will happen is, now it will give DMA acknowledgement over here to disk, right? Means now disk can transfer data over here inside direct memory access, right? And now this IO, which is disk, now that can transfer data over here, and that data that will be loaded inside buffer first, right? The data that will be loaded inside buffer first. Once that buffer is full, DMA will transfer that data over here inside main memory. So in fifth step, DMA will give acknowledgement to disk. That is regarding now disk can transfer data over here. In next step, disk will transfer data inside buffer, right? And once buffer is full, DMA will transfer that data over system bus, and that will reaches to main memory, right? So once that data is available over system bus from buffer, that main memory can read data from this system bus. So reading of the data, that is step number 8, right? So that is how steps are there. So probably now I think you are having idea about how exactly process is there, right? First, CPU will generate IO command. That command will be given to direct memory access. So direct memory access knows now disk will have to transfer data to main memory. So direct memory access will wait till disk is giving DMA request to direct memory access. Once that request comes over here, direct memory access will ask for control over system bus by hold signal over here, and in response to that, CPU will give hold acknowledgement over here. Once that acknowledgement comes, direct memory access will tell disk DMA via DMA acknowledgement, now you are ready to transfer data over here. So now disk is a slower device, remember this, and that slower device will have to transfer data to buffer first. Once buffer is full, that is step number 6, that data by DMA will be uploaded over system bus. So that data will be available on system bus now. Once that data is available on system bus, that data could be read easily by main memory, and now that data will get transferred to main memory. And this process will be repeated till this counter will get set to 0, right? But here, my dear students, there are few basic things that you need to know. Like this transfer of data from disk to main memory is happening, but that is happening via this buffer. So how exactly that data transfer happens? That depends on size of buffer. For example, as if your size of buffer is small, in that case, DMA could function in cycle stealing mode, and as if you have data size of buffer which is large, in that case, DMA may function in burst mode. Let us try to understand how exactly things are there. For example, as if we talk about cycle stealing mode, in that you will be transferring data word by word or byte by byte, right? So in cycle stealing mode, DMA will send data in terms of byte by byte or word by word. So one by one word or one by one byte, that is getting transferred in cycle stealing mode. How? First, this IO will fill this buffer. Once this buffer is completely full, after that only DMA will take control over system bus and it will transfer data over here. So that is what first thing which is happening in cycle stealing. And from name itself you can understand this. Cycle stealing means it steals only one cycle, and on that cycle the data of buffer that will be given to main memory, right? That is what the case which is happening. And remember, this is happening byte by byte or word by word. Now second mode, that is burst mode, or you can say batch mode. In some books you will be observing that is also referred as bulk mode. Now see, this burst mode or bulk mode or batch mode, that is possible only if you have large size of buffer. Why? The reason is here we are dealing with to transfer data from IO to main memory in terms of bulk. So as if you have larger size of buffer, in that case only that is possible, right? For example, if buffer size that is of 100 byte, then first this disk will transfer data inside buffer. It will fill complete buffer with 100 byte first. After that, in bulk, data will be transferred by direct memory access to main memory, right? So that is how things are happening in burst mode, batch mode, or you can say bulk mode, right? Now there are few essential things that I would like to explain you, like timings. So timings also explains you how exactly things are happening in terms of data transfer. Like you see, preparation time and second is transfer time. Let me explain you that by analogy first. You see, preparation time means what? Here we are dealing with to transfer data from disk to main memory. So here disk is transferring data to buffer first. Here see, we are not transferring data from buffer to main memory till this buffer is full. So disk is slower device, right? So disk will take time to fill this buffer. So this time period which is required to fill this buffer from disk, that is referred as preparation time. So initially we are preparing our data, right? Preparation is happening byte by byte via this disk to buffer. Once this buffer is full, you can say this time period is preparation time. And once this buffer is completely full, we will be transferring this data via system bus to main memory, right? So this is referred as transfer time. Data transfer from buffer to main memory, that is transfer time. Now you might be thinking like, why are we are discussing all those things? Let us try to understand this, why we are discussing this. See, when preparation is happening, when disk is transferring data to buffer, at the time that is preparation time, and at that time you observe this system bus is free. So as this system bus is free, CPU can utilize this system bus, right? And during transfer time, buffer is sending data to main memory. So at that time, this system bus is not free for CPU. At that time, you can say CPU is blocked in with respect to usage of system bus, right? That's why we are discussing this. So if you observe over here, timings, then preparation time, that is a time to fill DMA buffer, right? And during preparation time, CPU can execute any other program as system bus is free, right? That's why preparation time is referred as busy state. So in examples you will be observing, they will be asking you to calculate busy state or blocked state, right? So at that time you should have idea about how exactly meaning is there. Otherwise it will be a bit difficult for you to understand the question, right? So during preparation time, CPU will be in busy state, and during transfer time we are transferring data from DMA to main memory. At that time CPU will be blocked from system bus, right? So you can say during transfer time CPU is there in logged state, right? So in next coming videos, what I'll be doing is I'll explain you examples based on these modes and these basic parameters which are there in terms of preparation time and transfer time. So that will give you more clarity related how exactly we can solve problems based on direct memory access. I hope it is clear to you still. If anything that you like to share it with me, note it down in comment box. I'll be happy to help you. Thank you so much for watching this video.